Okay, in this problem, we're going to be looking at calculations that involve IV infusions. So a couple of key points, make sure that you know what it is that the problem is asking for. This could be a drip rate, which would be drops per minute, could be volume to be infused, which you might see abbreviated VTBI, IV pump rates that are always milliliters per hour, it might be a dose per time. Just make sure that you know what it is that you're looking for. A little note on rounding, remember that drops always need to go to the nearest whole drop. When it comes to a rate, usually milliliters per hour, we're typically going to the tenths place. Now, as we've said before, make sure that you know the rules at your facility or your university. Now, as we've said before, make sure that you know the rules at your university or your school as far as what they want for rounding, but I can tell you the NCLEX NCSBN typically is going to the tenths place. Make sure that you end up with the right units. You could be looking for a lot of different things like micrograms per minute, milliliters per hour, micrograms per kilogram per minute. So just make sure that you know what it is you're looking for. And then always verify appropriateness. Does it seem too high, too low? Just make sure that it seems like an appropriate dose. All right, let's do a couple examples. The first two, I'm going to do both dosage formulas and dimensional analysis, and the rest I'm going to do in just dimensional analysis. So the first one, the order is give 1,000 milliliters of LR over 12 hours. What rate should the IV pump be set? Remember, this is always milliliters per hour. So our formula is rate equals volume over time. Our steps, identify, convert, solve, and verify. So we've got milliliters, we've got hours. That's what we're looking for. We don't need to do any conversion. So let's go ahead and set up our formula. Our rate is going to equal our total volume over our total time, which is 12 hours. 1,000 divided by 12 is going to get you 83.33333 repeating. And so when we round to the nearest tenth, we end up with 83.3 milliliters per hour. Now let's look at this in dimensional analysis. Always start with what you're looking for. Transfer your units over. What do we know about milliliters? 1,000 milliliters in 12 hours. There we go. Same thing, 83.3 milliliters per hour. All right, let's do another one. So example number 2, a patient is receiving 133 milliliters per hour of normal saline. How much will the patient receive in 24 hours? All right, remember, rate equals volume over time. This is direct algebra, okay? Let's just insert these numbers. Our rate is 133 milliliters per hour equals the volume is what we're looking for over 24 hours. Straight algebra. Times 24 times 24, these will cancel. Volume equals 133 milliliters times 24 hours, which is going to get us 3,192 milliliters in 24 hours. That's it, that easy. Now, if you want to see what this looks like in dimensional analysis, let's come back here and say milliliters equals, because that's what we're looking for. What do we know about milliliters? There are 133 milliliters given every hour. Transfer your units up. What do we know about hours? We're looking for 24 hours. Again, 133 times 24, 3,192 milliliters in 24 hours. If you want to have an extra unit here, you could say milliliters per day because you know 24 hours is the day, 24 hours in a day. That's just kind of an extra step. You really don't need to do that. All right, let's look at the next one. Again, we're going to work with dimensional analysis from now on. A nurse is initiating an IV infusion of regular insulin to a patient in DKA. The order is to start the infusion at 8 units per hour. The available bag has 100 units of regular insulin in 50 milliliters of NS. At what rate should the IV pump be set? All right, automatically we know we're looking for milliliters per hour. So start with what you're looking for. Milliliters per hour equals. Transfer your units across. What do we know about milliliters? We know that for every 50 milliliters of NS, there are 100 units of regular insulin. Okay, transfer your units up. What do we know about units? Well, we've used this piece already, so let's use this one. 8 units per hour. Cancel units. We're left with milliliters per hour, which is exactly where we want to be. Then you're going to multiply across the top and divide across the bottom. 50 times 8 divided by 100 divided by 1 gets you 4 milliliters per hour. Does it make sense? Well, we know there's twice as many units per every ml. 8 units an hour being 4 mils an hour makes sense to me. Doesn't seem like we're going to overdose them with insulin. Okay, let's look at the next one. A nurse is preparing to administer ceftriaxone IV to a patient without a pump using a gravity drip set. The set is calibrated at 10 drops per mil. The order is to administer 1 gram of ceftriaxone in 100 milliliters over 30 minutes. What is the appropriate drip rate? Now remember, drip rate is always GTTs per minute or drops per minute. So again, we start with what we're looking for. Drops per minute equals. Transfer our top units over. What do we know about drips? Well, right here, we know that we are using a set that is 10 drops for every 1 ml. All right, transfer your units up. What do we know about mLs besides the one we already used? Well, we know that there are 100 milliliters, and that 100 milliliters needs to go over 30 minutes. Okay, so here's one little trip up place. You could also have said 100 milliliters is 1 gram. What would that have gotten you? Well, you would then have had to say 1 gram in 30 minutes and you would have duplicated. It would have been okay, but what we know here is we're looking for this minutes. And so whatever gets you to that minutes faster is the way you want to go, okay? So cancel milliliters, we're left with drops per minute. Now we're going to multiply across the top, divide across the bottom. So 10 times 100 divided by 1 divided by 30 is going to give you 33.333 repeating, but we're using drops, right? When we round drops, we round to the nearest whole drop. In this case, 33 drops per minute. Okay. All right, let's do one more. Nurse is doing a safety check and notes that the IV pump is infusing 22.5 milliliters per hour of norepinephrine. The bag says 4 milligrams in 250 of D5W. How many micrograms per minute is this patient receiving? So start with what you're looking for. Micrograms per minute. Okay, transfer your units across. What do we know about micrograms? What are we given? Well, nothing. So we convert. 1,000 micrograms equals 1 milligram. We know that's where we're headed, milligrams. Okay, what do we know about milligrams? Transfer units. We know that 4 milligrams is in 250 milliliters of D5W. Cancel milligrams. Are we where we want to be yet? Nope, so let's keep going. Transfer your units up. What else do we know about milliliters? Well, right here, we know that we're going at 22.5 milliliters per hour. Cancel your milliliters. Now are we where we want? Micrograms per hour? Nope, we need to be in minutes. So we do a conversion. 1 hour, 60 minutes. Cancel your hours. Minutes, micrograms, you're exactly where you want to be. So now we're going to multiply across the top, divide across the bottom. 1,000 times 4 times 22.5 divided by 250 divided by 60. You'll notice I skipped a couple of the ones. That is a personal preference. It's up to you. Sometimes I include them, sometimes I don't. Including them in your calculation just helps you to make sure you don't miss anything. So when we do this math, what we end up with is 6 micrograms per minute. So again, the final step is always verify. Does this make sense? Is it an appropriate dose? Well, with norepinephrine, we know we're typically looking at up to 30 before we get into sepsis protocols. So 6 mics per minute, that's a great dose of norepinephrine. So that's it for your IV infusion calculations. Now, it's up to you. You can use the formula rate equals volume over time, or you can use dimensional analysis. Either way, just make sure that you're using the appropriate units, that you're converting, and you're getting what the problem is actually looking for. All right, guys, make sure you check out all of the other med math lessons as well. We love you guys. Go out and be your best selves today. And as always, happy nursing.